I'm willing to bet you have no idea what's in this box. Well, apart from what I've already given away in the title. Yes, a graphics card is in here, but the way by which it is cooled is this super cool part. I really should have scripted this intro. Anyway, you're gonna enjoy what's inside. Stay with me.
If you're sick of seeing that same Activate Windows watermark over and over, snag an OEM license from SCD Key. You'll have a fully activated OS in seconds, and you can kiss that watermark goodbye. And be sure to use menu offer code GSL for that sweet discount.
So the graphics card in here is not cooled conventionally. It's not using a regular old air cooler. It's actually an AIO setup, but the unique part is how the radiator fits into the case.
Ah, yes.
This right here is the radiator. This side is the graphics card. It's an RTX card. I believe it's an RTX 2080. See, it's also got Alienware branding on it. This card was designed by Asetek specifically for Alienware's latest desktop PC lineup. So just so you guys can get an idea of how this looks before it is installed, you can see it's a pretty standard blower design from the front. Not that you would see this in a case. You couldn't turn this vertical because you would also have to worry about this. This needs to be installed in PCIe slots as well. You have the RTX logo on the side. You will see that. Now, the radiator will actually sit like that. I don't know if that's being picked up in the camera, but it'll sit under the card. One of my first concerns when I saw this layout was, okay, well, if your pump is in here, then how are you keeping any of the tiny air bubbles that are in the system from destroying the pump long term? Asetek said they ran plenty of tests with other AIOs that were set up in similar fashions, and they didn't see any long-term detriments to setting things up this way. So yeah, that's all I can really speak to long term. I can't do long-term testing in a 10-minute video, but we're gonna run some other tests, see just how effective this is. I did want to take this card apart just quickly here so we could see what we're dealing with internally. They told me this is a 6-pass radiator inside, and we've got, what I think, 5 Phillips screws on one side of the card, and then a few Torx screws around the back plate that are holding this black cover in. I think we can take it off now. Yep, there we go. Okay, so the radiator basically sits in here. It is covered up, but if I lift up a bit, you can see the fin stacks. So there are actually 6 of these, so 6 different passes. So fluid will go here, then here, then here, 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 and then out this tube back toward the GPU. Another thing you're probably wondering about, how this fan is getting power. They actually have a 4-pin cable running through this tube's braid here, so it's actually concealed. No other external connectors you need to worry about. Just plug the graphics card in and slot this card in below it, and everything should be powered. And of course, we expect this fan to increase its RPM as the card heats up. And lastly, I want to show you the backs of these cards. You can see this is the radiator side, and there isn't much back here. You don't want anything impeding airflow out the rear of this blower style radiator. Same goes for the graphics card, although most of the heat will be transferred to the radiator by design. Oh, and one more thing, yeah, no back plate, and to make matters worse, it's the ugly green PCB type. I've seen these in Dell PCs before, nothing new in that sense, but if they plan to bring these to market, which it sounds like they will, at least for some other DIY vendors, this needs to be addressed, IMO. So this is how the system looks with the card. I don't want to say dual card array, but it's not. Obviously, it's one graphics card and the radiator that looks like a graphics card. But it does look like you're running an SLI setup here. And this can be beneficial if you're interested in filling up. A majority of the space tends to be pretty dead down here unless you have a capture card or a second graphics card, which I don't recommend in 2020 for obvious reasons. This can be a great way to fill up that otherwise empty space. And if proven effective enough, could be a viable alternative to traditional AIO cooling for a graphics card. So now that we've gotten all that out of the way, I've shown you what it looks like with the card and rad installed into a system. We're gonna test it out. I'm gonna put it through a few different benchmarks. We're gonna run 3D Mark, Time Spy, and Firestrike. I'll probably do a torture, run a torture loop as well, just to see how the temps hold up long term. That's really what I'm curious about. We've gone with the Meshify C for optimal airflow. We're just using the stock fan setup, so one intake that's directed toward the graphics card and one exhaust that is exhausting air from the top and underneath the CPU. We're just using a 3600 with the stock air cooler. All right, let's get to testing.
So the 3 tests I ran were 3D Mark Time Spy, IDA64, and FurMark. IDA and FurMark stress the GPU to varying degrees, and Time Spy allows us to see how frequency and performance scale with respect to thermals under load. I included a Founders Edition RTX 2080 Super as a control, which relies on the same GPU, power config, it's all identical as far as I can tell, apart from the green PCB, so they're both reference model PCBs. As such, since we weren't locking fan speed in an effort to gauge apparent loudness, which is an important factor, it was also important to map frequency throughout our testing to see if there were any variances. Starting first with IDA64, which only moderately stresses the GPU, we can see how much hotter the FE model ran once the cooler was heat soaked. This process played out much longer for the Alienware AIO by nature of how water behaves when it's heated, so it was important to stress these cards for an hour or more at a time. The FurMark burn-in test was up next, and it pushed these GPUs to the limit. Not the memory though, keep in mind this is just a GPU intensive workload. The Founders Edition card reached 80 degrees Celsius at the diode, and frequency throttled down to 1650 megahertz. As for the Alienware card, temperatures were considerably lower, yet the card still throttled to its base clock of 1650, meaning that without some tweaking, we shouldn't see any performance difference at stock between these cards. Something else worth noting here, the FE model pegged 41.3 dB on my meter, while the Alienware card reached 43.2. This delta is significant on the logarithmic scale, and the difference in apparent loudness can be discerned between them. So despite the AIO and inclusion of water as a medium, the Alienware card, once saturated, actually ran louder than an air-cooled reference model from NVIDIA, and it really comes down to the blower-style implementation here. See, I don't think Asetek's goal was to have the quietest cooler around. Rather, they were tasked with shoving a fairly dense radiator into an Alienware case that didn't have the necessary rad support to begin with. And in that respect, I think they've nailed it. This card doesn't belong in standard mid-towers in my opinion, but instead works great in compact cases with minimal airflow but still 4 or 5 PCIe slots. The design isolates the generated heat from other components in the system as well, as demonstrated by the amount of heat being dumped out the back of the card, which is another reason why it's great for compact cases with minimal airflow. Lastly then, performance. So if the Alienware card runs cooler than an FE one, yet runs louder, we shouldn't expect any serious performance hit, right? Well, see for yourself. In 3D Mark Time Spy, the Alienware variant pulls in a graphics score of 11,589, and the FE model rings in a score of 11,660. They're within 100 points of each other, accounting for less than a 1% delta in sheer performance. So ultimately, the only thing I cared about at the end of the day was whether or not this card underperformed with respect to a Founders Edition model, what we would call our control. And it certainly does not. You can see, again, within a 1% delta here, that is something that many would chalk up to margin of error. If we ran these tests 10 times, I'm sure they would peg between 100 and maybe 200 points of each other, but it's nothing that you're likely to notice long-term or in real-world gaming. You also have to remember that water has a very high heat capacity, meaning you'll need to dump much more energy into it for its temperature to increase by 1 degree Celsius. So it's important that we got this testing right. Most people who play games are not just playing in 10 or 15-minute sprints, they're playing for hours at a time, and by then, definitely, you'll have heat-soaked cards, whether they're AIO cards or air-cooled ones. Now I know I have the advantage of hindsight at this point, but I can't say I'm fairly surprised by the results we just witnessed. This card is designed for a very specific use case, and if you keep that in mind, I don't think it's a bad card at all. It's not something I recommend anyone with a generic mid-tower, like something like a Meshify C. It just wouldn't make sense. This card is designed for more closed off spaces. It isolates the heat, it evacuates the heat out the rear, it keeps the internals of fairly compact cases from getting super toasty, which could definitely change CPU thermals as well, potentially VRM thermals. Now, you want to be careful about very closed off systems. If a card is running hot, that's one heat source, and then you have a CPU running hot as well, that heat can build up and it will affect long-term performance and potentially long-term efficiency and reliability. So this was a very fun project. I'm grateful that Asetek sent one of these out just for us to experiment with, test. I know that they've already done all this testing in-house. A lot of the stuff that I've discovered or talked about here, I'm sure they've already figured out for themselves. But it was cool to kind of just play around with it and see how viable it was for not only a regular old mid tower like a Mesh FIC, but also kind of look into how they designed it and the thought process that went behind the design itself. Now, if you guys like this design, this layout here, maybe the utilization of an extra 2 PCIe slots for a radiator, maybe just ditch the blower and go with some open air fans, depending on how you're still able to get the heat out of there. I'm not sure how efficient that would be, but if you want to see something similar to this on the market for DIY builders like ourselves, let us know in the comments below. Asetek is working on this for, I believe, other vendors at the moment, but I'm curious to see where this goes, if it goes anywhere. It's an interesting concept. It works in the right setting, but I feel like with some tweaks, we could see this become a bit more mainstream. If you guys like the video, thumbs up, click the subscribe button. I'll catch you in the next one. My name's Greg. Thanks for learning with us.